Hello there, welcome to this page. Today we'll be talking about resistors in series and in parallel. But for us to know this, you have to know exactly what a resistor is. So let's start. A resistor is a two-terminal device. So the reason why we are saying it's a two-terminal device, this is what a typical resistor looks like. See, one terminal on this side, the other terminal on the other side. So that's why we are saying it's a two-terminal device. And its main function, so the main function of a resistor is to oppose the flow of electric current. That's the main function of a resistor. So put this in mind. And normally when you are being given an electric circuit, and a resistor is being represented by this. So this is the symbol for a resistor in an electric circuit. Sometimes it's in this form. Sometimes it's in this form. Sometimes it's in this form. So the measure of the opposition is what we call resistance. So the measure of that opposition is what we call resistance. And the SI unit for resistance is ohms, or it's measured in ohms. So we see that the resistance is high when the S is high, when the level of opposition to is high, and it's low when the level of opposition to is low. So let's move on to our main topic, resistors in series and in parallel. So let's take the series first. So this is how a series connection of resistor looks like. As you can see, the same current will pass through I1 and I2. So the current I passing through them is the same, but the voltages or the potential difference across them differs. So I1 is equal to I2, but the voltage V1, so here will be V2, they are not equal. Put this in mind. They are not equal. So V1 is not equal to V2. They are not equal. So in case you are being asked to find the total resistance, the formula is just by summing their resistance up. So if they give you a circuit diagram and the resistors are in series and they tell you to find the total resistance, you just have to sum up their resistance. That's all. So RT equals R1 plus RT plus R3. Moving on. So let's take an example for you to understand. Find the total resistance in the circuit below. So if you think you've understood what I've said so far, you can try it. Pause the video and try it. If not, let's do it together. You have a 9 voltage source, a 3 kilo ohm resistor, a 10 kilo ohm resistor, and a 5 kilo ohm resistor. Kilo means is thousand, so kilo means thousand. It's just a prefix for thousand, so it means thousand. Kilo means thousand. Bear this in mind. So it's nothing special. So we have a 3 kilo ohm resistor, 10 kilo ohm resistor, and a 5 kilo ohm resistor. So it's simple. We just have to sum up their resistance. So it's going to be R1 plus R2 plus R3, since there are only three resistors, which is going to be 3 kilo ohms plus 10 kilo ohms plus 5 kilo ohms, giving us 18 kilo ohms. So note this, no matter the number of resistors that are given, to find the total resistance, you just have to add or sum them up, provide only if they are in series. So let's move on to resistors connected in parallel. So there is something opposite to the series connection or arrangement. So as I said, for the series they have the same current but different voltages. This time around, parallel connection, they have the same voltages but different current. Why do they have different current? So it's because of the presence of a node, this or a junction, the point A. You see, when the current coming from the voltage source reaches to point A, it will divide into two. One will move towards here, one will move towards here. So as you can see, one is moving here, one is moving here. So I1 is the current passing through the first resistor, and I2 is the current passing through the second resistor. They are different because when it's reached here, they separated into two. It's like you reaching a junction and they dividing. That's what's going on. So here, that's why I'm saying I1 is different from I2, but the voltages across them is the same. So that means V is the same as V1, and it's also the same as V2. Don't mind my handwriting. So V is equal to V1 and it's also equal to V2. So know this in mind. So in case you are being asked to find the total resistance in an electric circuit, the formula to use is 1 over RT equals 1 over R1 plus 1 over R2. Moving on. So in case you are given only two resistors, as in this, it's going to be 1 over R1 equals 1 over RT equals 1 over R1 plus 1 over R2. If we simplify this, you are going to get this. So the simplified version to use is this. But if it's 3 or more or 4 more, it differs. So let's take an example. So find the total resistance in the circuit below. If you think so, let's take the voltage source for here to be 3 volts. Let's take here to be 100 ohms, here to be 200 ohms. Okay, so if you think you've understood what I've said, you can try it. If not, let's solve it together. So as you can see here, there is a presence of a node. There's a presence of a node. So here the current that will pass here will be different from the current that will pass here. So I1 I1 will be different from I2. Okay, I think you understand what I'm trying to do. So I1 will be different from I2 because when it reaches here, some part of the current will pass here, another part will pass here. So the formula to use is 1 over RT equals 1 over R1 plus 1 over R2. This is going to be 1 over RT equals 1 over 100 ohms plus 1 over 200 ohms. So if you simplify it, you're going to get RT equals 200 ohms multiplying 100 ohms all over 200 ohms plus 100 ohms. So here, you see, I said in the previous slide that here you can use a simplified version which is R1 multiplying R2 all over R1 plus R2. That's what we used here. But one mistake students do is that, let's say they solve for here. After they solve for this part only, some students just say that's the total resistance. Please, that's not the total resistance. For you to get the total, this is equal to 1 over RT. This is not equal to RT. So after that, you have to cross multiply or something to get your RT. Please do get what I'm saying. You have to simplify further to get your RT. But this is not equal to RT. This is equal to 1 over RT. Okay, so I hope you've enjoyed the lesson. If you think you've enjoyed the lesson, please subscribe, follow, like for more, and please comment the next topic you want us to do. This is FC Star Crazy Technologies. See you next time.